Well, hello, everybody. Welcome to another episode of Communications and Conversations. That's right. We are back. We got a great show for you today. I think it's going to be a great show. Of course, I always think it's a great show, right? Because I host a show. But we are going to dive into some best practices on hotspot devices. And we're going to go and talk about a problem that people create with these hotspots, which is looping. You're going to take down a network if you do this wrong, folks. So if anything, you own a hotspot. A lot of other people do different shows and saying like, hey, blah, 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 blah. Here's how here's an awesome hotspot, all that kind of jazz on there. Yeah, hotspots are good. The opinion time, remember I always say when it's going to be opinion time here. I have a love-hate sort of with hotspots, but that's more so related to the aspect of what hotspots, how people set them up, right? I've seen so many videos, so many videos about people going ahead and just like, well, you just do this and this and this, and then you throw it on the air. That's how easy it is to set up. Enter your call sign, and it's like, no. There is some responsibility for hotspots, especially with the diversity of the hotspots out there. And what I guess I want this episode to do today is we're going to learn some of the things. If you're thinking about a hotspot, you're thinking about setting one up, you're thinking about getting one, I want you to think of these things going on because, back in the day, it was a simplex frequency. It was like UHF only and da-da-da-da-da. Now there's duplex hotspots. There's that act like mini repeaters. There are, VHF, UHF, 220, 900 megahertz hotspots. And it's just like they're all across the board now. And if you do it wrong, folks, you're going to create issues on systems or networks, and you're going to have problems. So we're going to cover this episode today, and then maybe in a future episode, maybe next week's episode. We'll see, how much time I have available and stuff like that on there. We're going to show you how to set up a hotspot. We're going to show you how to do it right, and we're probably going to do one for Pi-Star, and we're going to probably do one for WPSD, because those are the two basic OSs that hotspots run. So that is going to be today. We're going to talk about some understanding of, kind of an understanding of hotspots, and we're going to dive into looping on there. That's the biggest thing. Like I said, I take this kind of personally, this episode here, because I run a network on the amateur side, okay? And let me clarify this. We're going to be talking about hotspots for amateur radio usage. Yes, there are hotspot usages for non-amateur usage. Ooh, got to do the. There we go. So everybody gets a kick out of that when they do that there. So, yes, and then so that's one thing we're going to talk about is the hotspots for amateur usage. Kind of give you some things to think about, and then once again, I kind of take this personally because with hotspots, I run on the amateur side a multi-mode network. We cross over DMR, P25, Fusion, and we have different ways to get into those different modes. We're going to be looking at adding other modes too. We got rid of some of modes because, you know what, be honest with you, we got a couple of people who, I don't know what the deal is, but they were causing interference on different modes. I don't know if it's because the people were doing those modes and they don't like it. It gets weird, right? Who knows? That's them, not me. But we had to drop a few modes. But that's fine. That happens, right? You grow and expand and stuff like that. And one day you don't like broccoli and the next day you do. So that's what we're going to talk about today. Before we get into today's episode, we always got to take time to thank our sponsor. And our sponsor is JJK Communications. That's right. JJK Communications sponsors everything. They help keep the lights on in the studio. They help with all of our great, fantastic work and equipment and everything like that on there. But do you know that JJK Communications is a two-way radio sales, service, and provider, and also offering POC, push-to-talk over cellular devices. Now, why would you use a push-to-talk over cellular device? Well, here's an interesting and easy reason why. You want to have that reach. You want to have that ability to communicate in non-critical settings, okay? JJK Communications offers the JJK Elite. That's right, the JJK Elite push-to-talk system. That means that you are getting a great radio offered by JJK Communications that allows you to communicate whether you're local, your distance, your regional, you're even nationwide. When I travel, and those of you that know travel me, guess what? I take my push to talk radio with me here. Okay, that's kind of seeing the picture over here. I take that with me so I can be able to contact and talk back to my family in addition to those other radios on there. Now, if you're worried about, hey, these POC radios, what about when cellular networks go down and stuff? Yes, they do require cellular network connectivity, but also one thing all the radios at JJK Communications has offered through the JJK Elite product line is that they also can connect to Wi-Fi. Other services are like saying, hey, we got Wi-Fi now, and we're like, we've had Wi-Fi for years on there. So don't be rushed or rapidly pushed into some sort of type of POC network. Don't be fooled that, oh, you pay this one fee and it lasts forever. No, JJK Elite is fair pricing and no hidden pricing. That's right. All these other services out there that say they can do this and this and this and this and everything. Yeah, read the fine line on there, because guess what? There usually is some sort of fine line or fine print on there. No, JJK Elite offers that service on there. In addition, not only do they offer it for regular monthly usage, if you know you're going to be traveling with the family, if you know you need that, contact JJK Communications. They actually even offer rental. That's right, rental POC devices. Those other companies aren't going to do that. They want you to write out that big expensive check for each radio and say it works forever. And it doesn't. It does not. But JJK Elite stands behind their product line on there. So contact JJK Communications for all your communications needs. Alrighty. So let's talk about hotspots and networks, and more importantly, looping. So what is a hotspot? In essence, and the basic time is a hotspot is a term that was coined. I don't like the term hotspot, because back in the day when you had cellular devices that like, okay, you could use the cellular connection out of here to run Wi-Fi on those devices. That was a hotspot to me. I like to call these things as access points. That's what I like to use a term better, is access point, because what's happening is these devices are in essence little tiny access points. They have to connect to a network. They cannot stand on their own. They have to connect to something. And I'm going to pull one out of here off to the side, because we've been working on them for a little bit here. But here's an interesting one. There's many different ones out there, so don't feel like you have to go with this one or whatever. But this is on a Raspberry Pi board, as you see on there. This is the little single frequency, so it's not a duplex. It's a simplex hotspot on there, but that is attached to the device, and then that sits on there, and then you use a Raspberry Pi. But once again, you need the connection of the Raspberry Pi to go back to the network to be able to talk on these devices. So understanding that's why I call it an access point, because you're using something to access a larger network. All right. This isn't a repeater. All right. It's not. This is even if they're the duplex ones, they act like a repeater, but they only work when you connect back to a network. Okay. So that's going to be the biggest thing about access points, as I like to call it. Okay. Now, you may have heard me use a term in the past if you've talked to me and stuff like that, or you're familiar with our network, called the SFS. That's a single frequency site. Now, what that is a higher power than these. So these little hotspot devices and stuff only put out about 10 to 20 milliwatts, and they're usually UHF. Okay. And I say and because there's newer ones coming out. I got one actually on the bench behind me. You can't really kind of see me back there, but I got one back on the bench over there that is basically a duplex one that could do VHF, UHF 900. I think it even does 220. Okay. But anyways, has that aspect of that operation on there. So those I call single frequency sites, because those are simplex, but they are standalone sites that put out higher wattage. Okay, they put out 5 watts, 20 watts, 50 watts, those kind of things like that on there. They're basically like a base radio, simplex base radio. Now and then there's also when you have a network, there's like repeaters, right? So that's a whole different thing on there. But getting back to these little devices here, that's why I call it an access point. Now, when you're doing these access points, All right. When you're doing these access points, you have to keep a couple things in mind. And this is going to be that best practice part of the episode. And the best practice part is find a frequency that is not going to cause interference, but will work for you. Okay? Let me repeat that. Find a frequency that's not going to cause interference, but will work for you. Now, what do I mean by that? Because that's like what? Well, of course I'm going to find a frequency that works for me, but not. Well, we all share in the amateur band. Yeah, we do, right? But there are certain segments of the amateur band that really you don't want to play in because they're earmarked for other things on there. I'll give you an example. We've had this fascination with hotspots. I'm going to call them access points from here on out the rest of the video, right? These with the access points that they were throwing them automatically down in the 438 and 439 megahertz range. Okay. It's part of our amateur band. However, you would be surprised at some of these devices of what people do to these devices. First of all, it's a 10 to 20 milliwatt device. It doesn't have great filtering on these devices, folks. It's not. It's not meant for you to put to external antennas. It's not meant for you to amplify things on there, right? It's not in any way, shape, or form. But people will do that, and then that causes problems. And there was even times where it was actually interfering. Someone had reported that it was actually interfering with a satellite operation. I don't know about that. I heard the story, never really looked into it too much. So I was like, okay, I'll take your word for it. But it makes sense, right? I mean, if you have something transmitting on the satellite uplink in the 438, 439 area that right there, it could cause interference because the satellite's obviously looking down towards Earth and we're trying to transmit up to it. And if it's listening and hearing signals, it doesn't know a signal there versus, you know what I'm saying? So I could see that there. But what I mean by that second point is A, it's not going to cause interference, but B, it's going to be work for you. Now, there are radios out there that can go UHF. We'll talk UHF right now here. We won't talk VHF. We're going to talk UHF on the access points. That commercial, obviously, to do DMR, P25, those kind of things, you got to go commercially, and you have to go down to those areas there. So, okay, some commercial radios are not going to go down to 438 and 439. It's just a fact that it is. Some barely get into the UHF amateur band alone. And I mean, just getting the radio, programming it and saying, okay, it goes down there. Some will balk at you and be like, no, those kind of things. So in that regards, you need to select a frequency that's there. Now, here's why I say it's not going to cause interference. It's going to work for you. So some of my commercial radios that I use for like P25 and DMR, they're of the 450 on up split. There's other ones that I have, which are like the lower split that barely go up into the 460s. Okay. And then I have some radios that do the whole gambit of things. They do the whole 400 to like 512, right? Okay. So in that case and in those situations, that's something you want to see like, well, maybe I need to be more towards the top of the amateur band. Maybe I need to be in the 448 or 449 area on there. Now, this is once again where I say, you're not going to cause interference, but use the frequency that uses for you. So what are the things I tell people? They've come up to me and they said, John, what do you suggest for hotspots? What do you suggest for frequencies of usage? And I'm like, okay, let me ask you something like this. Where are you at in the U.S.? Because when we look at UHF frequencies, some places like I'm in the Midwest, right? We go in high and we come out low. So we go in to our repeaters and stuff on 445 all the way up through 449, and then we listen on 440 up to 444. However, you get out to the coasts and some near the borders, the U.S. borders, it's completely opposite. You go in low. You go in on the 440 to 444, and you come out on the 445 to 449. Blows my mind when I go out to the coasts on there because it's like, oh, wait a minute, I got to hit reverse. And I'm like, this is a cool thing because I was like, why would I ever have a reverse button on my radio? Well, now I know why. But with digressing, right, you want to use something that's there. Now, most repeaters in UHF band plan initially were 25 kilohertz. So, for an example, if you take a look at something, it'd be like 449, let's say 500. And then the next frequency there would be 449 Alrighty. Well, in between there, you have a buffer zone. You have a buffer area. And when you have that buffer zone, when you have that buffer area, what you can do is you can actually take and do 12.5 kilohertz channel stepping. So in other words, if you take 449.500 and then you're going to add 12.5 kilohertz stepping to it, now what you're getting at is you're getting the difference between the two. So you're taking, so think of it, you're taking 525 minus 500, okay? And that's going to give you 25. And then you divide that in half. Well, that's 12.5. So what you could do is you can program the radio into 12.5 channel stepping. And now what that's going to do is that's going to give you that step off of there. So if you take 449.5000 plus 0.125, so 0.0125, let me correct that on there, then you're going to get a channel frequency of 5125. Because then if you add that again to it, you're going to add the 0.0125. So 0.0125, that takes you up to the channel stepping of 525. Now, why do I say that? Well, because when you're in digital, you're going to be at a 12.5 kilohertz bandwidth. And when you're at a 12.5 kilohertz bandwidth, you can nestle yourself right in between those pairs. Now, let me back up here, because this is where people usually lose their marbles here on it when I talk about this. But they're saying, John, let me ask you something. If I'm on a 449.500 frequency and I'm on an analog UHF repeater, in theory, that's 25 kilohertz. Yep. Well, that would be 12.5 up and down from the frequency. Yeah. So my bandwidth could go all the way over to 5125. Yeah. Well, that's not, you're going to cause interference. Well, yeah. But here's the thing. As distance increases, the interference decreases, right? So if you put a hotspot or some sort of device access point on there and you put it at .5125, you're only going to go 6.25 up and below that frequency. So if you have enough separation, you can nestle those frequencies right in between there and not have interference with one another. Now, this gets into a whole thing there, and I've talked about it. I'm just gonna say I talked about it. Let's put it that way. I don't want to be mean to anybody, but there are some people like, I have an engineering degree because I watched I watched a Star Trek episode, right? And there are some people that actually have, engineering degrees, and there are some people who actually have, done studies and looks at this kind of thing. But this is what the fact of the matter is, because now you can start to get more granular in between those. So if you're 30 miles away, okay, let's even say 50 miles away from a repeater on .500 and a repeater on .525, you're 50 miles away from them, you're using your 10 milliwatt hotspot. Guess what? Or 20 milliwatt hotspot, guess what? Or access point. You're not going to cause interference to them. And if it's an input, you're not going to go ahead and have interference. Now, the next biggest question that a lot of people say is when you're choosing a hotspot access point frequency is, do you go on the input or do you go on the output of things? And there's two schools of thought on that. So some will say go on the output side of things. Some will say go on the input side of things. It all depends on what you're doing, because as we're going to show you here in a little bit here with the hotspot stuff, and interference and looping, you're going to see that if you have two hotspots or access points and you're running two different modes, you're going to want separation so they don't interfere with one another. So what I do is where I live, I actually do, and this is part of proper hotspot usage, folks, or access point usage, is where you're going to be using it, you need to do your research, okay? You need to do your research. So if I'm going to take my access point device with me somewhere, I will stop and look what's around the area to see, am I going to interfere with anybody there? If I'm going to interfere with someone, not going ahead in any way, shape, or form, going to be using that frequency set there. But that may require me to change the frequency of my access point. Okay. It really may. And you know what? That's the burden you have to bear in this case when you're running these devices. All right. There are newer hotspots, access points out there that actually eliminate the actual antenna connection. And what ends up happening here then is so this is the SMA connection on there. If you're watching on the video thing, it's a little antenna connection on there, SMA, like on your radios. But some actually now have a ceramic based and surface mount antenna. And those things are only there. You don't need to hook, in essence, screw on an antenna to it. It's right in that device. And that's even going to go ahead and do less coverage, less range. All righty. So in those cases, you may be able to be in a more heavily populated urban area that maybe has a lot of frequencies, and you're still maybe able to find one in quote unquote a repeater section on there. So do your due diligence. That's really kind of what I want to say on there. Now let's get into this big thing called looping. Folks, you got to do some planning also too, is we talked about planning. And what I mean by that is your hotspot access point devices are capable of selective access. What is selective access? Thanks for asking. Selective access means the signaling or the features or abilities to add things that only the access point / hotspot is going to listen to because you are transmitting it with your radio. So let's go through a couple of them real quick. On Fusion devices, they have DGID. DGID may even be, depending on what server or network you connect to, may be a requirement in order to go down a network or to a network. In addition, you may also need to use it for routing in your device. So some access point software, kind of OSs and stuff like that, they will say, well, if you set this up and do this, you can just change the DGID on your Fusion radio and it will connect to different networks and da-da-da-da-da-da. Okay, so that's one. Two, going ahead and looking at DMR. DMR have color codes in addition to time slots and talk groups. Color code is like a CT, CSS, DCS, or a PL, DPL tone, where that hotspot device access point would not listen to what you're transmitting on what talk group and time slot unless you have that color code. Use a color code. All righty. Next is P25. P25 has a NAC code, network access code. That is a code that is chosen by you, and it's a hexadecimal, right? It's a 3-digit hexadecimal, and that you would program into the hotspot access point and then into your radio, and when you transmit it, you do there. The default one for P25 is 293. I don't suggest you use 293. I suggest you make up your own, use your own, okay? Do that, all righty? In addition, don't use a NAC code of F7E, all righty? On P25, F7E is like color code 0 in DMR. It's like DGID 0. It opens up and it receives to anything. Don't use F7E for P25, okay? Put some sort of code in there. Next, we're going to go ahead and talk about NextN. NextN uses RAN, okay? RAN codes. And RAN codes are a variety of codes. Once again, a 3-digit code that goes up there. Choose a RAN code that's going to work for you if you're using NextN, okay? If you're going to be using D-Star, D-Star has call sign routing. Set those kind of things up on there. Properly there for call sign routing and access. And then finally, the last little bit here on setting up your hotspot, consider if you want this to be set up in public, semi-private, or private. Now, what I mean by public is you can set it up that anybody with any call sign or any ID can come by, if you're using like P25 and DMR and stuff, come by, can key up the device and be on the frequency and know all the access points on there and can key it up. What happens when you set up these nodes for public versus semi-private versus private, you could start putting, in essence, called a quote-unquote whitelist of what IDs or call signs are allowed to access that hotspot access point. So you could say it's like, okay, hey, and I've done this here, where I'll travel and I'll set mine up to be semi-private, where I create a whitelist of my call sign or my DMR or my P25 ID, okay? And then only I can access that. If someone's to come along, key up on there and say, oh, hey, I hear a hotspot or an access point, I'm going to key up on there, it will ignore it because of that semi-private or private thing on there. So thing to think about. It's all going to depend on, once again, your usage. So let's take a little bit of a kind of an understanding here of looking at how devices can be set up. So hotspots, once again, we talked about this. They are connected to a server. Now, servers, depending on the link, the connection, the type of server, can either be all hotspots, access points, could be all repeaters, or could be a combination of hotspot access points and repeaters together. Here's the biggest thing to understand about this concept. When one device is transmitting into the server, the other devices are receiving off of the server. Now, you may be saying, server, what I've never heard of that. Is that like a reflector? Yes, a reflector is a hot, how do I say it? A buzzword for a server. And that's really what a reflector is. And the reason they call it a reflector is you send a signal into the server and it reflects it back out. That's a D-star thing that they talked about a long time ago. I don't like the term reflector. I actually say server because your devices are actually connecting to a server. If it didn't connect to a server, like the internet, you turn on your computer. If you go to Google, it doesn't go to the Google server, right? It's not going to do anything, right? So same thing with these access point hotspot setups on there. So that's the first part about it, understanding that. Now, our first scenario of a looping incident. And what do we mean by looping? What I mean by looping is that you have a signal go into the server. That signal gets broadcasted out or sent out to the other devices. And then somehow, some way, that was what was just broadcasted from the server reflector is going to go back into a device, and somehow it's going to loop in the system. And it will loop, 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 and that's what it sounds like. And the only way to do it, to stop the looping, is if you're causing it, you got to turn off a device. You literally have to flip the power on it so it stops receiving and then transmitting back into the network, or the thing times out. And then if the thing times out, that could take up to 3 minutes, depending on how it's set up. So that is the first kind of loop. That's the definition of looping. So in the case here that we're going to talk about, our first incidence of looping, which happens a lot, is, remember how I said choose your frequencies and choose the right ones that don't cause interference, right? Don't have multiple hotspots on the same frequency, folks. Don't. That is stupid. I'm going to tell you that, hands down. I don't care if I offend you or not. That is the stupidest thing to do. That's like going in and saying, you know what? I'm going to park 2 cars in the same parking spot at the same time. Guess what? It ain't going to work, and it ain't going to be pretty. All righty? So that's the first one. In this case, what happens is someone transmits into the server. The server then spits it out, and we're going to use the example of 3 access points and a repeater. So 1 access point sends it in, the server sends it out to access point 2, 3, and the repeater. And the next thing you know is all of a sudden access point 1 goes in, sends it, server sends it out to access point 2 and access point 3 at the same time, but 2 then is transmitting into 3 before 3 has a chance. Okay? And then what ends up happening is if it unkeys, that loop will go around, because remember, digital has a little bit of a delay, right? So if I'm talking on a digital radio and someone else has another digital radio and we can hear each other, I'm going to be like that. You're going to hear that echoing because of the amount of time it takes for analog to come in or a signal to come in, to vocode it, to send it, to decode it, and then allow you to hear it. Or in digital layman's aspects, is saying the digital signal to come in, connect to that access point, be sent down the network, internet, to the server. The server then takes it and spits it back out to there. So that creates a delay, right? It's not as fast as what we think. There is a delay. But in this case, if you have 2 access point hotspots, or worse yet, I've heard this one. This is bad, where people are using a access point hotspot device to feed a repeater. Oh, Jesus Lord. And then that repeater's connected to the internet. Well, that's problems, right? You need one connection for that hotspot access point. And what I mean by one connection is you need only one RF connection going in and one server connection going in and out. But you can't have any others on there. So if I'm talking to my handheld or my mobile radio to my access point hotspot, I better not have any other radios talking into that, or if I do, they're users and not other access point hotspots. So that's the first one, is a hotspot looping on a hotspot. All right. Next one we're going to go ahead and talk about is this one, which happens a lot, which is server-to-server looping. What this means is that in setups of servers, now, usually you as an end user with an access point hotspot are not going to be the culprit in this case. That is usually going to be related to the server people setting it up and stuff. But it can be caused by an issue there depending on how your things are set up. So what you do is you have, in essence, a access point or hotspot or a repeater, something that's transmitting into the server. When you're transmitting into the server is not only sending it out to other users, but it's also sending it to another server too. Now that second server is picking it up, and that second server is, guess what? Transmitting it out to the different users and stuff like that on there, which then happens to be looped back to the other server. Or it's coming off of another server and it's being fed back into it by these remote devices. So then what ends up happening is at the server level, you're having a loop on a loop. And what happens then in that case is that it's once again, it sounds like you're talking like this, 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 because it's just looping a small amount because of that time, in essence, of when the devices or whatever is feeding this the information back in there, transmits, then goes in receive, transmit goes in receive, transmit goes in, so it goes back and forth like that. So in that case, it's a server to server. Now, server admins, if you're listening here, man, you have the due diligence to make sure your stuff does not loop. All righty? Make sure your stuff does not loop. Better yet, you as a access point hotspot user, don't be a dick. Yep, I said it. Don't be a dick. And go and take your devices and link to other networks. So another good case might this be in this case is that, let's say I'm connected to my AMCOM server YCS 313, and I'm going in, let's say on Fusion, all righty? And then what ends up happening is I'm going in on Fusion on that server. What happens then is that it's going out to the other networks, but then someone is sitting on another device somewhere, and they're listening to it, but they're feeding it into another server somewhere else, okay? And then what they don't realize, because they're thinking, well, I'd like to take this traffic off of the YCS server, and I want to put it back onto the DMR server. Well, then what ends up happening is they put it onto their DMR server, and then what ends up happening is that when it hits the DMR server, guess what? That talk group, that connection of the DMR server goes over to the YCS server, and when it goes over there, guess what? It creates a server and a server loop. How do you stop it? Well, you have to find out the culprit, the cause of it. Now, 9 times out of 10, when it's a server-on-server loop, believe it or not, it's not really a server issue. It's something someone has bridged or patched together. So that's why I can't stress enough. Don't, you as an end user using an access point or hotspot, go and do these kind of things. Don't do that on there like that. Don't do there. Now, the next type we're going to talk about is sort of a different bridge on here of a server on server. But what's happening is you're creating an RF loop using servers. Okay. Last one we talked about was the loop is at the server level. But this case, we're talking about going in on a device, going to a server, it spits it out to another device, which is received by another device, which goes in another server. So what you've done is you've linked 2 servers together, but you don't stop the as I kind of call it, the ion, right, traveling through there. So in this case, you have someone who initiates a call to a server using an access point, okay? And in this case, let's say the server then connects, the YCS server connects to the DR2X. So now let's say someone has a DR2X, and then that is going to feed and make a bridge to a Wires X room, which is totally fine. It's designed to do that way. But then what happens is that Wires X connection goes into the Wires X server, and then that Wires X server then is spitting it out to other Wires X nodes. Now, somewhere down the line, it comes out to that second Wires X node, which then happens to feed another repeater. that a problem yet? No, it's not. The issue comes in if that repeater connects back to the original server. Now it is. Now you have a server-on-server loop because of the device to a device. So you're not, in essence, like when we talked about before, having two devices on the same frequency locally causing that loop. What you have is you have, in essence, devices on the same frequency, which it's designed for, but someone else is doing that like another location away from you, and you're going through the server to contact that RF connection, and that RF connection causes through the server to contact that RF connection. What is caused by this? Well, this is people who don't know what the heck they're doing. And a good case example might be is that you have, we'll use just DR2Xs because it's easier to describe it with that way sometimes for people to understand. You have DR2Xs that are connecting together like through fusion. Through fusion. You can't do this in analog. I mean, you can't do it through analog. We'll just say that way. And they're going through it like the YCS server. And then what happens is that the one DR2X goes out to wires X and is connected into one room. Well, what happens is on the other end, someone isn't paying attention. And then in this scenario, they're connecting that wires X node that feeds their repeater into those same room. So therefore, you're looping. So here's the deal. You got to make sure that connections don't go to other connections again. That's the kind of aspect on there. So in this case, if they were in a different wires X room, would it work? Yeah, because you're going in and a wires X node is in room, was call it like mine, 21667, feeds a DR2X, which then goes into YCS server. The YCS server goes out to the other DR2X. And then in that case, if they're connected to room 43369, okay, that's not a problem because room 43369 and 21667 don't connect to one another. Not a problem whatsoever. But if you put that wires X node in there, it's looping the servers, but it's looping through external connections. It's not a server-to-server direct connection on there. So that is there. And that's the aspect of looping. But to finish it up, we brought it back. People like it. You know what really bends my antenna? You know what really bends my antenna is the aspect of things on people, once again, just think that I can plug and play with these hotspots. One, I've talked to many IT people. I do some IT stuff, and I don't know about you, but if you're in IT and you like the word plug and play, I think there might be something wrong with you because nothing is ever plug and play, especially these devices. You have to have some level of responsibility. Hotspots are becoming a popular thing because it gives the people what they want, which is their own little corner of the world, right? We all want our own little corner of the world, and that's what this device does. This is why these have started to fall out of sync with repeaters. Because if Bob and Doug hate one another in the club, Bob's not going to talk to Doug on the repeater, and Doug isn't going to talk to Bob on the repeater. That's it. Remember, you have two hams, you have one club, you have three hams, you have two clubs, okay? And in this case, what this does is it says, hey, I'm Bob. I don't need to talk to Doug because I hate Doug. So I got my little corner of the world that I could take my handheld and go ahead and talk around anybody I want to. If I want to go ahead and talk to somebody about fishing, I could talk to someone about fishing. And I don't need to go ahead and worry about anybody else jumping on and saying, Bob, shut up. We don't want to hear about fishing. That's in essence why hotspot activity has grown so much, because it gives you that. Okay, it gives you that. But you can't, once again, just throw it in there. It's like, do we all remember when we took driver's ed? We knew nothing about cars. We knew some things about cars. We knew, okay, growing up, you get in a car, turn on the key, and you stick shift or gear shifter, and you drove, and you got your gas pedal, you got your brake pedal, you got your turn steering wheel, and all those kind of things like that on there, right? Well, guess what? That's kind of what a hotspot access point is. I know I can transmit my radio into it, and it goes down in the network, and I can talk to people. But then you took driver's ed. And now driver's ed saying, no, you got to do this. You got to know this rule, this rule, this rule, this rule, this rule. And that is what comes down to these hotspot type devices. You need to know A, B, C, X, Y, Z. Because if you don't, you're going to be causing a ton of problems. And when you cause a ton of problems, then you got problems, okay? Because now you're having, now you are not only creating problems for yourself, you are possibly throwing garbage down networks. And now you are interrupting people. You are causing headaches. You are causing loop on a loop on a loop on a loop on a loop on a, right? And I'll tell you, a lot of this can be rectified. 99% of this can be rectified by proper operation. Now, why isn't it 100% rectified? Well, it's not. It can't be ever 100% rectified on there. It's not. There's that 1% which is going to have problems, which is equipment failure, issues with the internet, those kind of things. If you're talking, your internet drops out, that can sort of kind of cause a loop because it holds the network open. Those things. So there's a 1% thing of that's not your responsibility, but 99% of the proper operation and not causing loops is going to be in your wheelhouse, folks. All right. The other thing about hotspots, access points, which we're going to cover in next episodes, is doing the calibrations. You got to do calibrations. I hear so many people go and saying, well, this is a piece of crap. My radio is a piece of crap because it won't hear my hotspots. Yeah, I'm going to say it's not the radio. I'm going to say it's your hotspot access point that is not doing the job, or it's not set up correctly. That's a lot of it on there. And part of it is calibration. Okay, you got to remember when you have these devices, these hotspot access points, it's a tunnel, okay? And that tunnel does two things. It can let great signal in and push great signal out, or it can let garbage in and push garbage out. And that is where it's going to be problematic for you. So that's where you don't want to have these things in play here. So keep that in mind. Don't be a hotspot dick, okay? Use hotspots properly. Now, are there going to be times where people don't have hotspots? They're like, I've set mine up and I don't have a problem with it whatsoever. Yeah, you can. You can luck out and do those kind of things. But also, too, is you may be in a situation where you're not throwing out the ripples in the lake, right? You throw a stone into the lake and you're going to see ripples. You may be able to throw that stone in there and there's nobody else in the lake with you. You're not going to have a problem with that. So keep that in the back of your mind, making sure you're proper hotspotting. Now, here's the deal. If you have issues with your hotspot, part of one of the reasons I became an extra is to help educate people. I have a DMR server on Amcom. I have a cross multi-mode network, the Do Now network, okay? You can go in those multiple modes. Okay, those things require me to help you to be a good educator on there. And that's why we do the show here too, is to help you educate. We're not doing unboxing videos and all those kind of things like that, or giving comments or complaining instead and not providing solutions. This is an education, and I'm here to help you with your solution. So don't be afraid to call and ask for help on there. But guess what, folks? You know, I try to keep these shows to 30 minutes. Last episode and this episode, I really bombed that. But I kind of hope that you did take something away with it. I hope you did hear something on there, because it's so important to be able to do these things on there and do it properly. So thanks for tuning into this episode. We got some other ones coming up on there. If you're listening onto the podcast, hey, there's some graphics on this one. You might want to hop on over to the YouTube channel, take a look. And if you're on the YouTube channel, hey, I hope it made sense to you on there. Thank you for tuning in. Take care, everybody. I do appreciate you all. I do appreciate seeing you. And even the people that said, hey, I just found your show. It's pretty cool. Well, hey, the kudos are great, and I appreciate it. So until then, everybody, take care, stay safe, and guess what? I'll catch you on the radio.